Hi guys, I apologize for not being here today, but I am home with my son who is sick. I absolutely plan on being back tomorrow, so if you have any questions, come on in before school if possible. Feel free to fast forward through these and just go to the ones that you need. My guess is you probably need number 1, that was a doozy. So here we go. Now first, fill out what we know and go from there. This obviously, hopefully you realize that this is a bunch of chord, tangent, secant, or secant, secant problems. It's just quite complicated. AM is 9, AN is 5. Ooh, so right there, hopefully you're saying, oh, that's not bad. MN is then 9 minus 5, or 4. Oops, that doesn't look so nice. 4. And look at that. We've got the very first one that they wanted. MC is 12. That's hard to mark. BT is 11. That's hard to mark as well. And KT is 2. KT I can deal with. Okay, so I got some choices. I think I'm going to follow kind of their guidance here. They're telling me to find MG. MG is the external part of a secant. So I can either do secant, secant, or secant tangent. We have to stick with secant, secant because we don't have that piece of the tangent. So I'm going to redraw this. For MG, let's see. I'm going to have this picture right here. Where this is 4, 9. I'm looking for MG, so I'm going to call it X. And then they told me that MC is 12. External times whole equals external times whole. 4 times 9 equals X times 12. Giving me 36 equals 12X, and X is then 3. So now I've got MG is 3. And if all of MC was 12 and MG is 3, 12 minus 3 leaves GC to be 9. So let's see. I'll write that over here. So now GC will be 12 minus that newfound 3, and GC is 9. Okay, next one it says to find MD. Okay, MD is my tangent. So I'm going to do obviously a tangent secant. I think I'm going to stick with the secant that I know is right, the secant that they pretty much gave me all the information for. So I'm going to find MD over here. I'm going to redraw this. I'm running out of room. Pretend that looks like a tangent. So I'm going to call this Y. They told me, or I found that was 4, and then this was 9. And I know that it's tangent squared equals external times whole, leaving me with y squared equals 36, or y equals 6. Therefore, my tangent is 6. Running out of room, the next thing they need is BK and then GK. Okay, so BK. BK here. Well, if BT is 11, and we found out that, or excuse me, we didn't find out, they told us if BT is 11 and KT is 2, I'm going to write this over here, we know that BK is just 11 minus 2, or 9. Finally, leaving us with GK. GK is part of a chord. So I guess I'm going to squeeze it in here. Sorry, this is very not organized. We've got 9 and 2. We know it's part times part equals part times part. Now, a little while ago, we found that GC is 9. Since I'm looking for GK, I'm going to call that Z. And since I know GC is 9, this is now 9 minus Z, giving me the equation 9 times 2 equals Z times 9 minus Z. Oh, this is a mess. Try to zoom in there a little bit. let's see, 18 equals 9z minus z squared. Z squared minus 9z plus 18. We've done a bunch of these now. This is something we want to factor. And we'll get z minus 6 and z minus 3 equals 0, leaving us with z equals 6 or z equals 3. It could be either one. Okay, I'm going to erase this now because I don't want it going into there. Or not. Doesn't want to erase for me. Never mind. Okay, find the length of an arc that measures 45 in a circle with a radius of 20. Length equals measure over 360 times pi d. Length equals 45 over 360 times pi, and if our radius is 20, then our diameter is going to be 40. (45 over 360 leaves us with 1/8 of 40 pi. 40 divided by 8 leaves us with 5 pi. Okay, number 3, find the measure of a 4 pi arc in a circle with a radius of 6. So this is the same as before. Length equals measure over 360 times pi d. We just have a little bit different information this time. This time we want to find the measure, and we know that our arc is 4 pi. 4 pi equals, I'm going to call that x over 360. If our radius is 6, we have a 12 pi circumference. I like to get rid of my pi's, leaving me with 4 equals x over 360 times 12. Now we can do this a few different ways. I like to divide by that 12, and 4 over 12 is 1/3 equaling x over 360, and I now end up with 3x equaling 360, or x equals that 120 degrees. Okay, number 4. Concentric circles with center P. Okay, so P to the point of tangency is 7. P to A or P to B is 25. And now we also have to remember that anytime I draw a radius to a point of tangency, I create a right angle. Therefore, I now have 7 blank 25 or 24. Anytime I draw a radius to a chord and they are perpendicular, I split that chord in half, meaning that this part is 24, and I now have AB equaling 24 plus 24, or 48. Next one, we did something very similar to this on that practice quiz. We want to draw in our radius, but what is the length of that radius? Well, it's made up of 6 plus 4, therefore it's 10. We have a right triangle, therefore it's 6, 8, 10. And just like the last one, anytime you draw a radius perpendicular to a chord, you cut it in half, leaving us with AB to be 8 plus 8 or 16. Okay, next one, number 6. Let's see. AB is 16. Anytime you draw that radius perpendicular, it cuts it in half. So this is 8, 8 and 8. And then redraw that radius of 17, and we have an 8 blank 17, so 15. Same idea here. I'm going to draw that radius of 10. I've got an 8 and a 10, which hopefully reminds you of 6. Now the distance between O and P is 15 plus 6, or 21. OX is 3. CF is 3t minus 4. And we know that XP is congruent to PM. That idea is that when chords are equidistant, they are congruent. So this chord is congruent to this chord. Well, let's finish up and try to figure out what else we know. There had to be a reason for this 5. If I redraw this, I now have a 3, 4, 5. And that means that this full chord is now 8. Well, if I set 8 equal to that 3t minus 4, I get 12 equals 3t, and t is equal to 4. I don't like that. Let's see. Ignore a bunch of that stuff. Let's see. I'll ignore that. Technical difficulties. I'm not used to this program. Okay, so last one. Find the perimeter. Well, the straightaway pieces aren't that bad. It's just these circular figures here. Realize that this is half of a circle, so it's going to be half of the distance around a circle. Remember, area of a circle is pi r squared. Perimeter of a circle is pi d. So half of pi times 12, or 6 pi. This one down here is 1/2 of 6 pi, or 3 pi. Then let's think about this. If I have that this piece is 14 and this diameter is 6, 14 minus 6 leaves this to be 8. If I have 18 and I take away this 12, I am left with 6, giving me a 6, 8, 10. And I now have half of that 10 pi, or 5 pi. Putting this all together, I end up with 18 plus 14 plus 3 pi plus 5 pi plus 6 pi. Which comes out to be 32 plus 14 pi. Okay, there you are.